cognitive capabilities increase, or social capabilities increase, and also change. So the conversation gets more important when Sarah gets older, and MathBot becomes more of a companion rather than just a play buddy. And they talk about more intimate stuff, about dreams, for example. And as Sarah gets older, other things become more relevant. For example, becoming part of an in-group or being part of an out-group is very important when Sarah is, for example, 10 or 12 years old. And they talk about fears, even more intimate stuff, because that's more relevant for Sarah at her age. So these, it would be cool if MathBot would be able to adapt its behaviors to these changing developmental aspects, these developmental milestones in terms of, cognitive abilities of the robot, social capabilities of the robot, perhaps also physical appearance. A toy appearance would be best for younger children, but maybe a bit too childish for older children. So perhaps we could also alter the physical appearance of MathBot, maybe even allow the children themselves to change the physical appearance. So this is what I want to go towards. Of course, it's currently very hard and not done yet that a robot really adapts to all these individual changes, but that's the dream, the research dream. So what do I mean by this relationship? So I focus primarily on the companionship. So there are, of course, different types of relationships. You have, relationships with your parents and relationships with your friends, your human friends. And I wouldn't go as far as to claim that a social robot could be like a real friend like people can, but at least they can have fun while being involved in this complementary and reciprocal social interaction. And that's how Bauming-Gazzavey defined a companionship. So these are the types of relationships that I am aiming for between children and robots. And we see from research that if this relationship is there, it can actually support or strengthen the interventions we're aiming for. It can also, and I've seen it in my own work, that the novelty effect is, the robot is something new. Children are very interested in interacting with this robot, but this interest goes away rather quickly if the robot is not able to, keep them interested in some way. And I noticed that if children experience this relationship, this companionship, it's for them a new motivation to keep coming back to the robot and want to interact with them again. So this is at least my solution to overcoming the novelty effect. And I really see different stages in this relationship process. First, you need to form relationships, and then the robots need to be able to maintain them. And for me, where I want to focus my research more on is to grow this relationship. And I've worked on the relationship formation and maintaining this relationship, and I will discuss these past work or certain aspects of it, and hopefully also identify some directions we can go to really further grow this relationship. And I'm particularly interested in doing research to really focus on how to develop autonomous social capabilities for the robot. And in marketing terms, content is king. Without actual conversations that children can have with the robots, activities that children can do with the robot, that is what provides meaning to an interaction. So without the interaction content, the interaction is meaningless, basically. So we need to focus also on how do we get this content. So I'm rather focused on how to do this, rather than what is the effect of factor X, Y, Z on relationship formation, for example. It's important to know this because you need that information to develop and build these systems, but I want to take it a step further and really provide concrete ways for us researchers, but also for companies and other stakeholders on how to do this, on how to form this relationship and how to maintain this relationship. So that's what I'll be talking about a bit. So first, where are we now regarding the autonomous social capabilities? So we have this robot, and we want to do this autonomously. So we need some a lot of artificial intelligence to basically realize this. But the computing power on this particular robot, the Now robot, I use it often, but this goes, I think, for most robots, is very low. So we outsource all our computing to the cloud, basically. And we use all kinds of existing external services like Google Dialogflow for speech and intent recognition. There are all kinds of Python libraries and data sets to build all kinds of what we call social awareness services for the robot to understand what's going on with the child or with the context. And we use, this is of course the awareness side, knowing what's going on, but we also need something that does the action selection. So what does the robot actually do with all this information? So it has like, all the data from the robot is streamed to the cloud, and the data is sent to all these services to get some information about what's going on. And then we have an artificial cognitive agent to make sense of it all. So we have, we do this deliberately, because now we can come up with concrete rules about how the robot should behave in certain situations. And given all this information, it can select the most appropriate action to take. And I believe this is, at least I've implemented this system and it works very good. I don't think one AI system is able to, one end-to-end machine learning model, for example, is not able to do this task, because this task is too big and too diverse to, currently at least, let it be done by one single AI system. So basically this is a collection of all different kinds of AI systems with different properties to do this task. And the rules need to come from somewhere, right? So we need to have some way of defining these rules. And that's where interaction design patterns come in. And this is a concept coming from architecture. I will talk more about it. So because we have this strategy, we need very explicit behavioral design to let the robot behave autonomously, because without it, how we done it before is with Wizard of Oz studies, someone sitting behind the curtain touching the button saying what the robot should do. But if you really want to do the robot to do this autonomously, you need to have this explicit behavioral design, because it needs to come from somewhere, right? So actually, Christopher Alexander in the 70s came up with the concept of interaction design, of design patterns. And so he noticed in cities, for example, patterns of similar solutions to similar problems. So he started to capture these patterns and describe them, and they became guidelines for new architects to design buildings and cities using these patterns, because why reinvent the wheel every time? And in the 90s, this concept was used in software engineering, and in the early 2000s, this concept was also come to the human-computer interaction, mainly in user interface design. And I believe that we can use this concept as well in human-robot interaction, really defining concrete patterns of behavior for the robot in certain situations, and then we can, as a community, as a research community, but also, also interesting for companies to really build on each other's work in a constructive way. That's the whole goal, and it also makes, it allows for a lot of validation of these behaviors, sharing and reuse, and also for replication of studies, for example. Very important theme in our research community. Just like that these rules need to come from somewhere, the content also needs to come from somewhere. And of course we have all kinds of, large language models, for example, to generate new text based on basically trained on the internet. It can respond to any query with something that kind of makes sense, but of course, is it appropriate? And especially when working with children, it's not that appropriate. It's quite risky to use these models currently. So I went for a different approach. I collaborated with writers, with professionals who, for millennia are the content creators of this world. And why, not collaborate with them to create dialogues and activities for the robot? And we did this in what we call transdisciplinary writer rooms. We have programmers, we have interaction designers, we have writers, and together they come up with, what we call a story world. So this is basically a narrative description of who the robot is, what its goals are, and these goals can be fictional, but also, for example, one of the examples is that the robot participates in the Robo Olympics and really wants to be, the best, and it needs the child's help to train. This is a fictional goal of the robot, and a lot of content can be created around it. But it can also be real. For example, I want to help you with math, for example. That is a real goal. And a lot of content can be created around that. So that's the goal of the story world. And of course, you can have some fun with it. You can do some kind of artistic evaluation of this to, make this content even better. But of course, the real evaluation is when children are interacting with the robot. And the result is a lot of templated mini dialogues. What those are, I will explain in a minute. But it's basically a whole bunch of collections of anecdotes the robot has, things the robot can share with the child. And this becomes important later. So I want to focus on the relationship formation for now, for briefly. And the first step is, of course, to get acquainted. And you have the child getting acquainted with the robot, learning how to talk to this robot, especially if it operates autonomously. You need to get into a certain rhythm with this robot in order to have this communication flow going on, and you need to learn how to do this because speech recognition systems, they work pretty well, but there are some ways of talking to them that makes it more efficient. For example, slight pauses at certain moments are good, or sometimes it's bad, and you need to know to get in this rhythm. Another important aspect is that children have a lot of expectations about the robot. And this is also where the story world comes in. You can also create not only content for the robot, dialogues to say, but also this narrative around the robot. What should I, as a researcher, say when I introduce this robot? And how can I manage the expectations by the way I introduce the robot? And how can the robot manage the expectations themselves by showcasing what it can and cannot do, for example. This is all part of the getting acquainted process, and also that the child gets familiar with the robot. So who is this robot? Why is it here? What is its personality? What does it want? And of course, it's also important for the robot to get to know the child. And especially if you want to personalize the interaction, the robot needs to have a way to learn about the children's preferences and their interests and their what they want from the robot. So it's important to have some kind of interaction designed for this moment, this getting acquainted moment. And what we know from how people get acquainted is this is a very unstructured conversation typically. where people share things about themselves, and then some other the other party also shares something about themselves. This is what self-disclosure is basically. It's sharing personal information about yourself to another, but this comes with a certain risk. So if I share something personal about myself to you, I give you some power over me, because I don't know what you will do with that information. And if you in turn share something with me, then we balance this risk a bit. So this is the risk aversion theory of why people do this. That's why reciprocation is so important. It's not only about the child, opening up possibilities for the child to say stuff to the robot, and the robot, acknowledges it. No, it needs to go further. It really needs to at least respond to the child, but also disclose something about itself. And there are, of course, it's up for debate whether robots actually can self-disclose, because the self is inherently a human aspect. So by definition, in principle, inherently the robot cannot self-disclose, but the robot can disclose stuff about itself, of its fictional self. Let's say it like that. So we create a fictional character around the robot, and it can disclose from that character description. So it's not technically self-disclosure, so that's why we call it robot disclosure. Let's just give an example. It's in Dutch.
Als je zou moeten kiezen, wil je dan liever voetballen of liever dansen?
Voetballen.
Waarom vind je voetbal liever om te doen?
Omdat het mijn eigen sport is. Ik zit er zelf op.
Another example.
En wat is jouw lievelingshuisdier?
Een hond.
Waarom is een hond je lievelingshuisdier?
Omdat ik die heel zacht vind en heel lief.
So even if you don't understand Dutch, I guess you could see the rhythm of this conversation. So the robot asks a question, and then the child can answer, and then the robot responds again. And it is this fixed turn taking that makes this possible to do this autonomously. And this is also necessary. So this is what we call a structured dyadic design. So this is a compromise we have to make in order for this conversation to happen with an autonomous robot. And of course, it can become a bit artificial. And I guess the solution for that is to have really interesting content. So if the conversation is interesting enough, children will accept this back and forth turn taking, and they don't, it becomes part of the robot's quirky character, basically. So that's also why it's important to have this high quality content, otherwise this becomes boring pretty quickly. And it's the open type of questions that the robot asks, which it, in a lot of cases, can't really process the answer, but it gives the children space to share about themselves. So if we would only restrict to what the robot can actually understand, then the conversation will not have enough room for the children to really express themselves. So we also make compromises the other way around. So, okay, we don't understand what the child is saying, but we need to give the child this space in order to be part of this conversation. And hopefully in the future, the speech recognition technology becomes better and better, that we can actually understand these open answers better and better, and we are getting better and better at that part as well. How the robot responds to these things like, a dog is my favorite because it's like cuddly and stuff like that. How the robot responds to these things is very important. So we actually studied two different, what we call replication strategies. We have an explicit response, like, oh yeah, that's my favorite answer too, my favorite too, really matching. And then the robot has this disclosure like, oh, a dog is my favorite too, and then it gives this argument like, oh, I like to play catch with dogs, something like that. And we have a more nuanced approach where we thought, okay, well, this is obviously better if the robot also sometimes, not always, like it's just 1/5 of the time, it likes something else, to give the robot more character. So we thought, okay, the robot is more authentic, and in this nuanced strategy, and it will result in eventually more self-disclosure by the child if the robot is more authentic. So that's what our hypothesis is. And we also measured how similar the children felt themselves with the robot, but we expected no difference there because the content is basically the same. So we thought, well, it discloses more or less the same content, and in 4 out of 5 of the time it's actually matching. So no, it's not as big difference. So we don't expect a difference there. So we included 30 school children. We had this between subject study with these 2 conditions, explicit and nuanced, and we measured how much children disclosed, how authentic they thought the robot were, and how similar they thought they were to the robot. And interestingly enough, it was the explicit strategy that resulted eventually in more self-disclosures by the child, and not the other way around like we expected. And also, they thought children felt more similar to the explicit responding robot. So, that it makes you think. And so we thought, well, maybe it's this sentence, that's my favorite too, that really highlights the similarity that could cause this effect. And also this positive affirmation the robot gives that, your answer is something, you gave a good answer, children really like to do the right thing. And by this positive affirmation the robot gives, it might, reduce the risk for children to self-disclose more. And this could be possible explanations of this effect. Of course, we need to do more research on these relationships to figure out what's really going on. But this is indeed interesting for a lot of research. And what happens often is that the exact manipulations are, in the grand scale of things, not that different anyway, regarding how the robot is evaluated. So these things are, this is a behavioral measure, and the similarity is something the children feel about themselves, basically, and the authenticity is an evaluation about the robot, and that's often very hard to find differences in these single session studies, because it's the first time they interacted with the robot, and there's a lot of things going on. So these aspects are not that important for the authenticity, for finding differences in authenticity. But it's something you see often with these robot type evaluations in these single session studies. And let's move on. In a different study, we replicated a getting acquainted conversation study from the 2000, where students were paired up and they had this getting acquainted conversation, and they used the notion of positive effect, that if you measure positive and negative effect before and after this interaction, and if you see a positive change, that would be an indication of relationship formation. That's from Baumeister's and Leary's theory about relationship formation. So they used this principle in their study, and they found actually that positive effect increase was predicted by how much the participants of this study perceived that they self-disclose to the other, and the social attraction to the other party. And our hypothesis, okay, we will find the same thing between child-robot pairs. And 75 children participated in this study, and we measured positive effect, and we measured self-disclosure, not only the perceived, but we also actually counted how much information children shared and how intimate this information was, in addition to the original measures, and also social attraction in a similar way as the original study. And so our first question is, did we indeed find shifts in positive effect? And we did, and we mainly saw it in the positive direction, significantly in the positive direction, but also a small subset actually had a decrease in positive effect. So for these children, the interaction was not as they hoped, or at least they probably didn't form this relationship. So this is very important to figure out what was different in these conditions. Was it something, child factors? Is it something about the child's initial expectations or about their attitudes in general towards robots? Did they feel well that day? Or was there something about the robot that we could improve to cater to these children specifically? But I won't go into that. What more important for now is that we indeed found the same effects. So we indeed found that self-disclosure and social attraction also between children and robots are predictive of this positive effect change, meaning that self-disclosure is important for relationship formation and also social attraction. So this is something we need to design for. So indeed, facilitating self-disclosure is an important aspect of our design mission, basically, for child-robot relationship formation. And interestingly enough, we found that there was no correlation between the amount of self-disclosure and how much people perceived they self-disclosed, but there was a correlation between the intimacy of self-disclosure. So, and of course, if you think about it, it makes sense that people probably, if they have to assess how much they self-disclose, they're not going to think about how many information items did I shared, but how intimate were these things. If you shared something very personal, then you would perceive that you self-disclosed more. So this, again, for our design mission, it's very important to, we need to facilitate this aspect. So we need to design comfortable conversations that has an appropriate level of intimacy, and over time, if you think about growing this relationship, this intimacy must increase. So the robot needs to deal with that appropriately in order to do this. How much time do I have?
20 minutes.
Yeah. All right. The next step is moving on from racial information to maintaining it. And I really believe that social personalization, as I've been calling it, so personalization is, of course, tailoring something about the robot to the child's individual needs or characteristics or preferences. And you can do that in a lot of ways. For example, in the math context, you can adjust the level of the difficulty level of the math sums to the child. You can adjust the type of feedback you give, but I like to personalize, make it more on a social level. So, for example, if I learn about you that you like horses, then I will, talk more about horses. And also, and this sounds very trivial for us, but it's harder for robots to do this, is to accurately and relevantly remember things about previous conversations and bring it up during the current conversation. Starting with the name, so that the robot remembers your name. This is technically simple to do, but then also to integrate it in the conversation in a comfortable way. That's already a bit harder, but it's something we can do. But there's a lot of other types of information, like the pony riding example. How does the robot know? Okay, this is something relevant that I need to remember, and then actually remembering that the child is going pony riding this weekend, or at least hoped it would go pony riding, and then ask about it the next time. So this is more difficult to do, especially to do this in an autonomous way and keep it appropriate. But that's a problem that I wanted to tackle, or at least making a beginning of tackling that problem. I noticed currently there's a lot of discussion about, okay, what is long-term? Do we mean sustained or repeated interactions? So in this context, I just mean, let's make it practical. For example, weekly tutoring sessions in school or in the hospital. If a child has chemotherapy, they usually stay at home but come to the hospital for a few months during the chemo treatment, for like weekly or twice a week sessions for chemotherapy. And then they would interact with the robot in these moments. So this is what I now mean with the long-term interaction. So this is a few months, but it can be a year, and eventually I want to go to something that's multiple years. But that's not something that's part of this. This is just for a few sessions over a longer period of time, and also very short sessions, so max 30 minutes. And the vision that I have for this is that we see these interactions like a serial TV show, like a Netflix model. So each session is a new episode, and there are overarching narratives for the whole season of this series. But also, there's room within each episode to have, thematic things or special things going on in one episode. And of course, the child and the robot are the main actors in the story. So it's not a generic fictional story. It's really about the child and the robot. And the parents and the medical professional and the researchers, they have a supportive role in this show, basically. And this is how I, brought it also to the writers to create content. And this also helped for them. Okay, now we know basically what you want from us, to frame it something from their world. So that's what we did. We created what we called mini dialogues with the writers. So we have narrative mini dialogues, which are basically, so a mini dialogue you can see as similar to a paragraph of text, but then in a conversation. So it's just small things that are dependencies and relationship between these mini dialogues. If you listen very carefully, like dependencies and all kinds of relationship between individual items means, okay, if I have this metadata about a topic, for example, about the mini dialogue, you can do some reasoning and select the right mini dialogue at the right time. So that's basically the technical background. The content background is that we have narrative mini dialogues. So these are typically sequential dialogues with a storyline, and there can be multiple storylines, and then they can be combined, interwoven in this conversation. For example, like I said, the robot trying to participate in the Robo Olympics, so the robot is dreaming. So what does the robot dream about? And there are chit-chat mini dialogues, so these are more topic-based, for example, about favorite food, and there are topic openers. So, okay, what is your favorite food? And then a conversation about that, and follow-ups about it, about pizza, for example. And you have functional mini dialogues like greetings and stuff like that. These are the building blocks of conversation. And with all the metadata that goes along, we can do this reasoning based on the children's interests. So we have some design patterns to personalize this. Like I said, the name, it's nice to be remembered by the robot. Have these personal references, so let's talk about your favorite sport, taekwondo, or like a generic alternative, let's talk about a cool sport, football. So this is also gearing up towards a user study where we compared this personalization versus generic alternatives. You can make references to past conversations. You can select the mini dialogues based on certain narrative choices that children have made. So if the child is able to, I don't know, pick what kind of dress the main character of the story wears, this choice persists over time. And topic selection, like I said, the preferences of the child are used to choose which mini dialogues are selected. Another thing, you can also do some extra things. So one of the things is that we developed a way for children to create a secret handshake with the robot. They can actually move the arms around and select a song and stuff to it. And then the robot would do this every time they would see each other. And this is very powerful, we've seen. And also content motivation. So, you know, if the child's favorite food is risotto, for example, I'm not sure which child would pick this, but just for the example, you know, the robot could use this explicitly to start up a conversation. And this is, you know, it's important because the child feels it is being heard if the robot does this. So that's why we do this. I think I have a video about this as well. Yeah, this is subtitled, by the way, so this is already an improvement from the last video's.
Even door naar wat anders. Ik heb namelijk iets bijzonders ontdekt. Heel veel eten dat heel veel kinderen heel lekker vinden. Begint met een P. Zoals pizza, pasta, pannenkoeken, poffertjes en patat. Welke P vind jij de allerlekkerste P?
Ik vind pasta het lekkerst.
Fantastico. Dat is Italiaans voor geweldig. Dat heb ik geleerd van Italiaanse robots die pasta maken. De robots kunnen natuurlijk geen pasta eten, maar al die verschillende vormpjes vinden wij te gek. Wat vind jij eigenlijk lekker aan pasta?
Ik vind de saus die erbij komt het lekkerst.
Zo, dat klinkt goed. Ik hoop dat er snel een robotvariant komt van pasta. Hey Mike, gisteren dacht ik aan jou en dat we het vorige week over je lievelingseten met een P gehad hebben. Ik heb opgeslagen dat jouw lievelingseten pasta is. Gisteren heb ik voor het eerst zelf pasta geprobeerd te maken. Dat lijkt me handig om te leren. Daarmee kan ik jou en heel veel andere mensen heel blij maken. Heb jij wel eens zelf pasta gemaakt?
Ja.
Cool. Dan kun je vast wel raden wat er bijna mis is gegaan. Ik had een pak spaghetti klaargezet. Ik had wel zin in pasta carbonara. Maar in de eerste stap van het recept stond: zet een pan op het vuur en dus smelt daarin de chocola. Dat vond ik wel een beetje vreemd. Maar ja, het recept zei het. Maar toen alles klaar was, had ik niks meer aan de spaghetti. Wat voor soort pasta denk je dat het recept was?
Chocopasta.
Het was een recept voor chocoladepasta. Bizar. Zo'n foutje zou niet zo handig zijn op de robo spelen. Zullen we weer verder trainen? Ik ga nu weer rusten.
So now you see, I guess, the power of dialogue, of creating good content. So even if you find it funny, then imagine how funny children find this. So I will go over this briefly, so we have some time for discussion afterwards. So we had 5 sessions in a 2-month time with these types of dialogues. And I would expect that if these memory-based personalization patterns were used, that children will feel closer to the robot, self-disclose more, and show more positive social cues to the robot, and that children are more willing to continue interacting with the robot. That's the main goal, basically, is to facilitate and maintain this relationship over time, and hopefully children will keep coming back to the robot. And we measured closeness, self-disclosure, the valence of social cues, and the willingness to continue. And these things are all relationship measures. And what we noticed is that if personalization used, beginning with willingness to continue, it really stays stable over time, and there is it's rated on a 5-point scale, so 1 to 5, and you see that basically almost all the time it's already high. So I guess that's, if you look at other work, it would go down sooner than this. So I guess this is the power of this content again, because that was, the main storylines and everything were the same across conditions. It was just personalized or non-personalized. But even having good content already makes children wanting to keep coming back. And if the robot personalizes the content, this, at least for 5 sessions, stays the same, while it goes slowly but steadily goes down, mainly after the 3rd session. And if you look at closeness, we see no difference between, we measured it only at the 1st, the 3rd, and the 5th session. We see no changes, significant changes between the 1st and 3rd session, and then a big drop. So our explanation is, well, in the beginning, and we see that often that children rate the robot as what could be. They don't have enough experience with the robot to really assess or want to assess how they experience it. They still live in this, what could this robot, could this be a friend, and rate it as accordingly. But after 5 sessions, they really rate the robot more as is, so as what they've experienced so far. And of course, the robot is less a friend than they would want it to be. But if it personalizes, it's more. So that's the main message there. And we see a similar pattern to the willingness to continue for social cues. So children show more positive social cues like smiling when it personalizes, and this quickly drops to when it's not personalizing. So typically, children will just stare at the robot, be there. So it indeed is a new motivation for children to keep coming back to the robot, and memory-based personalization does foster the child-robot relationship and maintains it over time. And doing these long-term studies is very important to get past the novelty effect and really see how the robot performs realistically. So one single session study is often not enough to really see what the robot would do over a longer period of time. And we need to invest in this quality content. And to wrap it up, but I'm more interested into what you think should be the next direction, so maybe we can discuss a bit about this. But I want to know, of course, is this content created by writers is nice, and we should not stop the collaboration, but it's not very flexible and scalable. So can we find a hybrid solution for creating content using the power of AI and the power of writers? I work more on social responsiveness in a multimodal session, use non-verbal communication. We have seen that the robot asks the questions now, but I also want the children to be able to ask questions about the child, and to really look at, okay, what does personalization mean over these longer periods of time, like multiple years. So these are basically my research foci for the next coming years. But I would also love to hear from you how you think we can work on growing the relationships. So thank you for your attention.